Quick little video just introducing balancing of equations. The one side has like just some guided notes. Describe what you already know about each of these. Conservation of mass is just this idea of whatever we start with, we have to end with. Nothing can just appear or disappear. So all of the same number of particles we start with, we have to end with. It's going to ask you what you know about a chemical formula. We've seen quite a few of them. They look like this. They look like this. They look like this. We know that they're made of subscripts that only apply to what's to the left. And it said to put an example. For instance, up here, that means that there's 2 H's, only 1 S, there's no subscript, and 4 oxygens. Once in a while, though, there will be some parentheses. Finally, coefficients. A coefficient is a big number. Like if I wrote H2O, that would be 2 H's and an O. But if I put the subscript 2 in front of it, it means I have 2 water molecules, grand total of 4 H's, grand total of 2 O's. So this subscript applies to everything in the following formula. So we're supposed to do some balancing of equations in such a way that we'll put some coefficients here, here, and here in such a way that there's the exact same number of particles on one side as the other. Some people can do this right on their paper. Others may end up choosing a whiteboard and showing some things on a whiteboard. Still others may end up using some little of these. Be smart with them, but we could put these out representing different atoms. Different people learn different ways. I'm just going to draw this one. I'm going to draw an Na, and I'm going to draw a Br2. I'll use a different color for mine. That's a Br tied to a Br. And they're saying it's going to make an Na, Br. That just can't be. You can't start with 2 things, 2 Brs over here, and only end up with 1 over here. They can't disappear. So apparently, it's got to at least make 2 NaBrs. Now does that follow? That also doesn't follow the law of conservation of mass. You can't start with 1 Na and end up with 2 Nas. So apparently, there was another Na. Now it's balanced. They're the exact same numbers and types of particles. Now I put the coefficients. There's 1, 2 of those, so I put a 2 in front. I only made 1 of those, so careful. It's 2 Brs, but it's only 1 Br2 molecule. I don't need that coefficient. I'll put it for now. When I'm all done, I made 2 of these formula units, which we usually call molecules. That's a balanced equation. Some people will balance in a simpler way. On this side, you need to have both the correct coefficients and also a diagram. Some people will draw the diagram and add the coefficients like I just did. Others will know how to balance it just by looking or by counting, and then you can draw the diagrams. I don't care which method you get there. It would also be possible to, like I said, take some of these and just sort of put them on your paper and have them represent it, and then you can move them around.